This animation of a flame spectrophotometer will provide an idea of how the machine works. The analyte is taken into the nebulizer where it is vaporized and conditioned to provide the best sample for the flame. The radiation source sends light through the flame and into the monochromator. In the monochromator, the beam encounters a series of mirrors that separate the beam from any background light and noise that is not necessary for analysis. This filtered beam finally hits the detector, which relays the data to the analysis software. This is the gas that feeds the flame. These are the lamps that provide the source of radiation. The lamp is specific to the analyte. The analyte is taken into the flame by this capillary tube. Data collection is performed by software installed on a computer. This demonstration will use a sample of copper. First, start by cleaning the sample capillary with a chem wipe. Then, insert it back into the sample to be aerosolized, mixed with gases, and released into the flame. The flame turns a green color that is distinctive of copper. Waste is then siphoned off into a collection bucket. The data is then sent to the computer for analysis.
With atomic absorption spectroscopy, AAS, substances can be tested with regard to their elemental composition. Today, the process is used everywhere in industry because it is very fast and extremely precise. In this way, the exact composition of substances can be maintained and possible contamination ruled out. Even the quality of drinking water is monitored in this way. In medical applications, AAS is used to find evidence of important trace elements or even poisonous substances such as lead in blood. AAS takes advantage of the fact that all chemical elements absorb different parts of light. Depending on the element, a certain part of the wavelength of light is swallowed. For this reason, based on the wavelength spectrum of a sample, the elements present can be determined. To perform the analysis, the sample is first heated to 1500 to 2800 degrees Celsius, which dismantles it into its individual atoms. Graphite tube technology is used quite often here because it achieves the highest evidential accuracy. Electricity is used to heat the sample in the graphite tube incrementally to 2800 degrees Celsius. Then it is quickly cooled. For this reason, the requirements here are extremely high: the highest degree of purity, suitable electrical resistance, and extreme temperature stability. The patented Omega tube by Chm580, a graphite tube with an omega-shaped cross-section, ensures ideal indirect heating in this case. This is why graphite tubes by Chm580 are used all over the world. Chm580 develops and manufactures products made of carbon and graphite for use in spectroscopy. Thanks to specially developed materials, the company can supply components of the highest purity with extreme temperature stability for use in atomic absorption spectroscopy and many other analytical processes. Chm580 has established itself here as a leading global supplier.
different element has different emission levels. Emission rate or intensity of radiation is directly proportional to the population of excited atoms or concentration.